Hi guys, we're on 4C notes now, page 78 in your booklet. We're going to continue talking about functions, inputs, outputs, ordered pairs, and in this particular video we're going to use a graph, this guy right here, to analyze the function at some different points where the example number 1 is asking us to do. So it tells you that this is the graph right here of f of x. Y, the output, is a function of the x, meaning the x is the independent variable and y depends on him. So let's go back and review this terminology really quickly. A function pairs an input with an output. So the output depends on what you put in the function rule. On a graph, each point has an ordered pair, which we've talked about ordered pairs, associated with it. Each one, every single point on this graph has an ordered pair where x is the input, the independent variable, and y is the output, the dependent variable. So we're going to use this idea as we go down here and we look at this particular graph. They're telling us this graph right here, y is in fact the output, and it is a function of what x, the input, is. So it says, write as an ordered pair. We want, this is red, and I'm glad that they put this in the notes. This is red, f of 2. In other words, negative 2 is the input value. What is the output value? What would the y be if you had a negative 2 for x? So if we go over here on our graph and we go over to negative 2 on the x-axis, it's right here, and we want to find the y on our graph that's associated with this negative 2. Where does the y intersect? So we go right up here, and that point right there is where negative 2 on the x-axis meets the output on the y-axis. So we're going to write that as an ordered pair. The ordered pair is going to be negative 2 for the input, or the x, and it is what? 1, 2, 3, a positive 3 for the y, or the output. Let's do f of 0. What is the output when the input is 0? So if we go to 0 on the x-axis, where does that meet up? So here's 0 on the x-axis going horizontally. I'm looking to see on this blue graph, where does it hit the y-axis? And it's right here at positive 1. So f of 0, when x is 0, y is positive 1. What about when x is 4? What is f of 4? So we go over to 4, 1, 2, 3, 4, right there on the x-axis. And on the y-axis, we don't have to move up or down. It's sitting right there. The graph is on the x-axis. So in fact, f of 4 is going to be 4 and 0. And what is f of 6? Let's go over 6 on the x-axis. 1, 2, 3, 4, 5. Here's 6 right here. This is an interesting answer because f of 6 is not defined on our blue graph. It starts at this dot and it ends at that dot. There is no f of 6. So this is not defined. For this particular equation regarding this graph, there is no f of 6. Let's look at one last example to end this video, and it says, for what values of x? Now we're not looking on the y-axis, we're looking on the f-axis. Is the output, is y, because remember, you can think of this f of x, you can kind of replace it in your mind with the thought y. Where is y equal to 2? What x values have an output of 2? So let's go to 2 on the y-axis, which is right here, and now we go see which points have a y value of 2. So we go over horizontally, there's one, that guy, and we start here, we go over here, there's another one. So there are actually 2 points on our graph where the y value is 2. What are the x values for those 2 points? Well, if we look at this guy over here, we count 1, 2, 3. Positive 3 will get you to 2. And if we start here and we go negative 1 and up, that will also get you to 2. So there are actually 2 x values, 3 and negative 1, that both have an output value of positive 2. Okay, thanks for listening. I'll be back.